In this lecture, we continue our discussion of correlational research with an example. And in this particular example, it's illustrated here that a research study sought to examine if there is a relationship between the time a student wakes up and their overall academic performance. And so you can see the time here using standard time, and academic performance is quantified as a GPA out of a maximum of 4.0. And in this particular study, this included 8 research participants. And you can see a range of different scores for both wake-up time and academic performance. The first step we usually take with a correlational study is making what's called a scatter plot. And a scatter plot just so named because the data appears to scatter on this graph. And what we post on the x-axis in a correlational study is what we would refer to as the predictor variable. And the predictor variable is a term that's often used interchangeably with the independent variable. But in terms of a correlational study, the independent variable term is replaced with the term predictor, and that is the wake-up time, as you can see here. And our y-axis, oftentimes referred to as the dependent variable, where the value depends upon what value is taken along the x-axis. If this is a correlational type of study, then we replace that term with the criterion variable. And so what we're examining in this scatter plot is if there is any pattern that appears to emerge between the predictor and the criterion, and the blue line represents something called the regression line, and this is something that we'll address later on in the course. So in terms of interpreting this relationship here, what we see generally, the way the data scatter, is that there appears to be what's called an inverse relationship. And what the inverse relationship between these two variables tells us is that as the x variable increases, the y variable value will decrease. And we might interpret this saying that the later a student wakes up, the probability of having a lower academic performance is moderate or moderately high. But we would make that statement based upon the statistical outcome of this. So for our purposes here, we're just making a visual inspection as to whether there is a relationship or not. So to summarize the correlational type of study, the key points here is that we have to identify the outcome variable of interest. In the previous study, the outcome or important variable to the researchers was actually academic performance, and that's what we call the criterion variable. The factor or the variable that would seem to influence the value of the criterion variable is what we often would call a predictor variable, and that's what is plotted on the x-axis. The term independent variable is often used interchangeably with the predictor variable, but it's important that if we're talking about a correlational study that we use the term predictor. Now, once the data are in hand, as that is illustrated in the table on slide 25 in the top right hand corner, the first step really before conducting any sort of calculations is to make a graph of the data, make a scatter plot, and perform what I call the intraocular test. And really what that means is that the researcher that made the graph should just look at the graph, look for any pattern, and arrive at some subjective impression. Does there appear to be some emerging pattern in the data? If there is an emerging pattern, or if there is no pattern, does it make sense? And when I say does it make sense in terms of what the researcher might have hypothesized the outcome to be? Can the pattern be explained psychologically or physiologically? And so the suggestion here is to not rush and start performing calculations right away. It's highly recommended that the researcher examine graphs, look at the data, get a subjective impression, and how does that impression compare against what the researcher intended or thought would happen when these data were collected. So this ends this particular video on the correlational study.